Next we're going with osmosis. So osmosis is the diffusion of water. Okay, it's the movement of water across a selectively permeable membrane, but it has to do with sorry, I'm reading all this, one sec. Okay, so osmosis has to do with two things, okay? You're going to get movement of water due to solute concentration, and if you go back to the videos on properties of water, we talk about the thief hiding his loot in a vent, so the solute goes into the solvent. So your solute is the things that are in the solution, dissolved in the solution. So osmosis is regulated by the amount of things, the amount of solute concentration dissolved in solution, and osmotic pressure, which I'll get into in just a second. So water moves from an area of high concentration gradient to low, but we need to look at, let me draw it over, it'd be a lot easier if I draw it. Here's outside the cell, here's inside the cell, and I'm going to do water as circles. So we have 1, 2, 3, 4 water molecules here. 1, 2, 3, 4 water molecules here. So in terms of a concentration gradient difference, there isn't a concentration gradient difference, right? Because they have equal amounts of water. But if we looked at the amount of solute dissolved in them, so for some reason, let's say that we're looking at sugar. So now I'll do red circles for sugar. If I have this here, and now I have all these solutes on the outside. What we want to ask ourselves is, we're looking at the solute concentration, not the water concentration. Okay? So what we want to say is, we want to say this is high concentration of solutes. This is low concentration of solutes. The next question is, well, which way does water move? So if we're looking at this specific process, okay, so since we're looking at the movement of water, since this is high concentration of solute outside the cell, low concentration of solute inside the cell, what I do now is I say, okay, osmosis is the diffusion of water. So now we want to look at water's concentration of high to low. Before, I already told you that was hard to do because we were looking at the water molecules and said, wait, there's 4 on each side, that's equal. But now when we look at in relation to solute concentration, this is going to be a much more concentrated solution than this is, because this has all these different solute particles. So water is going to move in a way where water is high to low. Water is going to move from high to low concentration to balance out these solutes. So here, let's say this water molecule goes over there and this water molecule goes over there. So after the diffusion of osmosis, or the diffusion of water through osmosis, now we have this over here, and we just had these 2 water molecules. So as you can see, because water has moved from an area of high concentration to an area of low concentration, we get more equal we start to move towards equilibrium in the concentration of our solutions. So I know this is confusing, so let me do it again. We have a plasma membrane, you have water on the outside, you have water on the inside. We're just looking at this, you don't know how water is going to move. So next you have to look at your solute concentration. And this time we'll have this on the outside, and on the inside we'll have even more. So I'm switching it up this time compared to our last scenario. So now I'm going to ask myself, I'm just looking at solute concentration because I don't know how water is moving yet. When I look at this, I say, okay, well, I know inside has high and I know outside has low, but we're not looking at the movement of these solutes anymore. That was diffusion. We did that a couple slides back. Now we're looking at the movement of water. So now whenever I define high solute, I have to define low water. When I define low solute, I have to define high water. So now I ask myself, now I have my concentration of high and low, and I say, well, I know this is a passive transport, which means I move from high to low, so we know water will move this way into the cell. Basically, water moves to dilute the more concentrated solution, if you want to look at it that way. This is really concentrated compared to this, so water is going to move into the cell to make these reach an equilibrium. All right, that is osmosis. It's the passive diffusion of water across a semipermeable membrane. And when you ask yourself, how do I figure this out? Look at the more concentrated solute side and label that as the low concentrated water side. Then say, okay, well now I have low concentration solutes. That means I have high concentration of water. Now in your picture, you should have something that says high solute, high water, low water. And then you say osmosis, diffusion of water from high to low. Move your arrow from one side of the cell to the other. Okay. So again, bottom line, we're really looking at the amount of solutes to determine the way water will move. Okay. This other thing he talks about is osmotic pressure, and what this is. So what osmotic pressure is, it's the amount of pressure that water exerts due to having solutes in it. Okay, so here's a cup of water, and it's just water. So here's my water. Now, if I put another glass, here's that. Here's my liquid. If I do this now and I put some solutes in it, remember these solutes are moving around. So if they're moving around and they're hitting the walls, they're suspended in fluid, so really the water's hitting the walls. So this is creating some sort of pressure. This is called osmotic pressure. Osmotic pressure is the pressure of water, so pressure of water, because solutes are dissolved in it. So here's a real life example to try to conceptualize this. You have a train, okay? This is looking from the top down, okay? If you're looking into the car, the train car, so you have a head there, I'll just, whatever, I can make these bodies, it doesn't matter. This is how many people I have on the train right now. When I get to the next stop, it says, move, passengers are boarding, please hold on. So now I have my passengers coming in, and now I have 6 guys. If you've ever been on a really busy subway, you know eventually you're getting pressed up against this wall whether you like it or not, right? If you have this thing completely full of bodies, you're literally squeezing against the wall. It's the same thing in a cell. So if I have a cell and I have a certain amount of water in that cell, well, once I start putting things into that cell, the water has to go somewhere, and the only way it has to go is this direction. So that means once I start adding my solutes, I have pressure build up, pushing water in this direction, and this is called osmotic pressure. So as you add solutes into solution, it creates osmotic pressure, which helps with osmosis too. So the two things we're looking at with osmosis is solute concentration as well as osmotic pressure. I think in this case, for this test, I would focus more on solute concentration because that's going to bring us into tonicity, which is next.